This video will demonstrate the advanced setup in specifying the manufacturing stub length option of the backdrilling routine available from within the Allegro PCB Editor. This value is used to verify that the remaining stub length after backdrill is manufacturable. This design has had backdrilling run on it once. There was no manufacturing stub value specified, so let's take a look to see how this option works. So we need to go back into manufacturing and see backdrill setup and analysis. The manufacturing stub length variables are set in the drill parameters tab. Remember, this is a fabrication vendor driven value, and you shouldn't get this confused with the minimum electrical stub length requirement that you used by setting the property backdrill underscore max underscore PTH underscore stub. So this picture shows you what we're trying to accomplish. In this case, there's a connection from, let's say, the top layer board to an internal layer, which is specified by the must not cut layer. So in this case, we'd start back drilling from the bottom layer of the design, which is the start layer, up to the layer before that, which could probably be a pre-peg layer. And what we'll make sure is that the value marked in the manufacturing stub length is big enough to allow for the tolerance of the manufacturer's drilling process. So we're going to specify a value of 10 mils for the stub length. So I'll just type in 10. And as soon as I do that, it's already taken into consideration. So let's go back to the layer pairs and see what happened. So you notice I have some yellow cells and some white cells. The white rows are layer pairs that can be drilled successfully, meeting our manufacturing tolerances, and the yellow cells are ones that cannot. So for example, let's take a look at the top to layer 4P, which is marked as being able to be manufactured. So we're going to cut to layer 4P and not cut layer 5, which is where the actual connection resides. So we need to take a look at what's going on between layer 4P and layer 5 in our cross section. So bring up our cross section form and notice that, so basically what we have is layer 4P's thickness is 1.2, so we have to take that in consideration. However, the dielectric between 4P and 5 is 16. So if we add those two up together, we get 17.2 mils, which is greater than our 10 mil. So we can cut up to layer 4 and not infringe upon layer 5 successfully and meet our 10 mil minimum manufacturing stub. Now let's take a look at one of the other cells being identified as a problem. Let's take a look at, let's say, bottom to layer 4P. We can click in this cell and the system will tell us why there's a problem here. And again, this is the same value as before, so we're going from the bottom to layer 4P. So the must not cut layer is the layer above that 3. So we'll take a look at what's going on between layer 4P and layer 3. So we go back to our cross section. Layer 4P is 1.2 mils thick. We add that to the dielectric between the two of them, which is 8. That's only 9.2 mils. That's less than our 10 mil minimum requirement. Therefore, this is being identified as a problem for the manufacturer, a potential problem for the manufacturer. Now we can continue at this point and go ahead and generate our back drilling information, and we can generate it, but we have to make sure the manufacturer knows there's potential problems here. Now we can have the system automatically take into account this back drill stub and try to adjust the layers that are going to be generated. So let's take a look at how we do that. So let's get out of the back drill setup form. And what we need to do is set up a user preference to tell the system we want you to take into account the back drilling manufacturer stub. So we need to go into the manufacturer folder under another folder called drilling, and there is a preference that you set called backdrill layer pair adjustment. And what this is going to do is it's going to try to look at that backdrill stub value and redo all the calculations for us. So we'll say okay here, go back to our manufacturer NC backdrill setup and analysis, go into our layer pair initialization. And again, we're going to run this with minimized electrical stub length, but remember, we are now looking at the manufacturer stub at the same time. So we'll create that layer pairs. Let's go take a look at our layer pairs. And let's take a look at what happened here. On the left is the layer pairs that we generated before we used the manufacturing stub. And on the right is the results of what happened when we set the manufacturing stub length and told the system to use that. So from the top start layer, you can notice that the two layer pairs that used to be to layer 2P and layer 3 got moved up one layer. So layer 2P, which had 55 drills, is now going to top with 55 drills. And the one that was to layer 3 with 220 drills is now going to layer 2 with 220 drills. So we moved those layer pairs up to meet the manufacturing stub requirements on the top side. On the bottom side, the same thing happened on our bottom two layer pairs. From bottom layer 2P and bottom layer 4P, you notice they got moved up yet one. Notice though something happened with layer 6, from bottom layer 6. That was 11. Now bottom to layer 7P, which had 10, is acceptable because we have enough distance to match. So if we go on the right hand side, you notice that from bottom to layer 7, we now have a total of 21. So that combined the old layer 7P, which was acceptable, and the layer 6 were unacceptable, but it combined those together and we ended up with 21 plunges on bottom to 7P. And the next two bottoms got moved up one layer pair, just like in the rest of the examples. All right, now that we understand all that, we can continue on with the process now. Notice that down at the bottom it says our back drilling is out of date. So we need to regenerate the back drill information. So we'll hit the back drill button. And if you have that variable set, the back drill layer pair adjustment that we set a little while ago, and you run the back drill routine, you'll get this warning just to make sure you understand that the back drilling layers have been adjusted for that manufacturing stub length. So we'll say OK. Now we have generated all our back drills. We can take a look at the log file real quickly to see what really is going on here. And again, here's all of our layer pair information. And if we go down to where the back drilling actually occurs, and let me try to expand this out so we can see everything here. Again, the columns on the right, we're looking at the maximum depth. Again, that's actually the back drill plunge depth. So we're going to layer 2P, which matches the 10.10 there. Going to layer 3 is 19.3. That's that one. So that's what that represents. The maximum played through stub or maximum PTS stub column is the electrical stub defined on the net using the appropriate property. And the remaining stub length column represents the distance from the shifted must not cut layer to the actual cut layer, the connection layer itself. So this is the 2-layer plus the dielectric thickness. This concludes the video that demonstrated the advanced setup in specifying the manufacturing stub length option of the back drilling routine available from within the Allegro PCB Editor.